Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the sum of random variables. And this is the previous examination question. The example is find the probability density function of a random variable w defined as sum of x comma y with the densities shown below. Fx of x is 1 by a into u of x minus u of x minus a, and fy of y is 1 by b into u of y minus u of y minus b with a less than b. So coming to the solution, given that the density function of x is fx of x is equal 1 by a into u of x minus u of x minus a, fy of y is 1 by b into u of y minus u of y minus b. So, u of x, according to the definition of the unit step function, u of x is equal to 1 for x greater than or equal to 0, and u of x minus a is 1 for x greater than or equal to a. So, u of x minus u of x minus a is the rectangular function between 0 to a, and its constant value is 1 by a. So, similarly here also, u of y minus u of y minus b is constant value for y is equal to 0 to rectangular function uh, for y is equal to 0 to b, and its constant value is or magnitude value is 1 by b. So in its graphical representation shown in here, and this is the graphical representation of 1 by a into u of x minus u of x minus a. This is the graphical representation of 1 by b into u of y minus u of y minus b. So we know that the sum of two random variables density function is fw of w is equal fx of x convolution fy of y, which is equal to integral minus infinity to infinity fx of x into fy of w minus x dx. So now here fx of x is 1 by a into u of x minus u of x minus a, and fy of y is 1 by b into u of y minus u of y minus b. So now we are the substitute fx of x, fy of y is equal to w minus x. In fy of y expression, substitute y is equal to w minus x, we get fy of w minus x is 1 by b into 1 by b into u of w minus x minus u of w minus x minus b. So therefore, the density function of two random variables fw of w is equal integral minus infinity to infinity fx of x. This is fx of x, and this is fy of w minus x. So 1 by a into 1 by a 1 by ab, multiplying this term into this term, multiplying these two terms, we get four terms. Applying the integration into each term, we have fw of w is equal to 1 by ab into integral minus infinity to infinity u of x into u of w minus x dx minus integral minus infinity to infinity u of x into u of w minus x minus b into dx minus integral minus infinity to infinity u of x minus a into u of w minus x dx plus minus into minus plus integral minus infinity to infinity u of x minus a into u of w minus x minus b dx. So using unit step function definition, first applying the definition of the unit step function, u of x, u of w minus x, u of w minus x minus b, u of x minus a, u of w minus x. U of x is equal to 1 for x greater than or equal to 0. This is the definition of the unit step function. So now we are the first integral term. The second unit step function is u of w minus x. So using definition of the unit step function, u of w minus x is equal to 1 for w minus x greater than or equal to 0. So w minus x greater than or equal to 0 means w greater than or equal to x. So therefore, now here the x greater than or equal to 0 and x less than or equal to w. So therefore, the range of the x is 0 to w. And the second integral term, the first unit step function is u of x, and the second unit step function is u of w minus x u of w minus x minus b is equal to 1 for w minus x minus b is greater than or equal to 0, w minus b greater than or equal to 0. Here x greater than or equal to 0, here x less than or equal to w minus b. So therefore the range of the x is equal to 0 to w minus b. And third integral term, the first unit step function is x minus u of x minus a. U of x minus a is 1 for x greater than or equal to a, and the second unit step function in third integral u of w minus x. U of w minus x is 1 for w minus x greater than or equal to 0, for w greater than or equal to x. This x greater than or equal to a and x less than or equal to w, therefore the range of the x is in third integral term is a to w. And similarly in fourth integral term, the first unit step function is u of x minus a is 1 for x greater than or equal to a, and second unit step function is u of w minus x minus b is 1 for x less than or equal to w minus b. So now here in the fourth integral term, the range of the x is equal to a to w minus b. Applying all these conditions into this integration, this equation, we get fw of w is equal to, okay, first separately simplifying the first integral term, and the first integral term is integral minus infinity to infinity u of x u of w minus x dx. So in the u of x is equal to 1, u of w minus x is equal to 1. Now we have the range of the x is 0 to w, integral 0 to w 1 dx, integral 1 dx is x over 0 to w. Substitute upper value of x and lower value of x, we get the first integral term is w. Next, simplifying the second integral term, u of x is 1, u of w minus x minus b is 1, 1 into 1, 1. Now here the range of the x is 0 to w minus b. This is already explained in previous slide. So integral 1 dx is x over 0 to w minus b. Now substitute upper value and lower value of x, we get second integral term is w minus b. And third integral term, integral minus infinity to infinity u of x minus a into u of w minus x into dx. U of x minus a is 1, u of w minus x a is 1, u of w minus x is 1. For x is equal to a to w, and simplifying that one, the third integral term is w minus a, and simplifying the fourth integral term, and its value is w minus b minus a, and substitute all these values into all these integration values into this equation, we get the density function of sum of two random variables is fw of w is equal 1 by ab into w minus of w minus b. Minus of w minus b is minus w plus b. So minus of w minus a is minus w plus a plus w minus b minus a. So now here plus w minus w plus w cancel, plus b minus b is cancel, plus a minus a is cancel. So 0 by ab is 0.